Okay, so today we are solving this 1829 maximum sort for each query, and we will solving the way how we present the solution in an interview. So I haven't solved this question, so I'm like going to solve this, and let's see if I able to solve it or not. So this is maximum sort for each query, and the question is you're given sorted array nums of size n. Okay, we have a sorted array size n. Non-negative integers means positive integers, okay, and an integer maximum bit. Okay, you want to perform the following query n times. Okay, n times means the number of size. Okay, so find a non-negative integer means positive integer which is lesser than 2 to the power maximum bit. So okay, 2 raised to the power maximum bit is basically one left shift that bit. Okay, so and such that nums0 or nums1 until nums length minus 1 can XOR k is okay, so k is the number we will choose, and we have to like XOR the whole array with this k, and that should be maximized. Okay, and k is the answer to that ith query. Here is the answer to the ith query. What is ith query? Where is I? There is no I here. K is the answer. Oh, okay. So I think we need to like predict this number. When we solve with the rest of the number, it should be maximized. So K is the answer for that. Okay, got it. And let's see, next is remove the last element from the current array. So each operation we have to remove the last array as well. So then answer I, and answer I is the query answer to the ith query. Okay, so we need to return an array. Okay, here let's see an example and like understand it a bit more. So we have this nums, we have maximum bits are 2 and output is 0 3 2 3. So how it is, first query nums is this and k is this, since zeros or 1 2 0 is 3. Okay, so I and k is equal to answer is 0, so k is 0 and the answer is 0. So basically they choose a k is equal to 0, which maximize the whole XOR of the array of the list. Okay, then secondly we remove this last element. Now the nums become this one and we choose k is equal to 3, and then it becomes again the maximized 3, and similarly. Okay, so once it's maximized, will it be needed to maximize, this will be same or not? Let's figure out this one thing. See, we need to maximize it, and to maximize a XOR, how to maximize a XOR, we will look into it, but this can be different. This cannot be like same because the array is altering every single time, so the result can be different. But okay, let's see, for this example 2 3 5 4 7, we choose k is equal to 5 and it makes 7, and that's same in all of them. Okay, so 2 3 4 7, we need to XOR it. A XOR operation basically means 1 XOR 1 is 0, 0 XOR 0 is 0, but 0 XOR 1 or 1 XOR 0 is 1. Okay, so for we need to maximize the whole XOR and the k, we should maximize that. So let me just write it down. I'm not writing the whole nums thing, I'm writing simply this 0 XOR 1 XOR 2 XOR 3. Suppose our array is, let's take this example, 0 1 1 3 1 1 3, and we have this initially, the whole array basically 0 1 1 3, and now we need to find something, some k that is maximized. So let's see. First I'm trying to find the XOR of this. So the XOR of this will be 3. So 3 XOR k should be maximized, right? For each we need this XOR and we need to maximize this XOR and we need to find a k. So in a XOR, let's do one thing. Let's write 3 in a binary representation. So it's 1 1, and we need to find a k. But how do we find a k? K can be maximum bit. Let me see the constraints as well. What's the constraints here? So the maximum bit can be like 20. Okay, and num size should be from 0 to the power maximum bit basically. Yeah, okay, got it. So all the numbers between the bits. Okay, and now it's sorted in increasing order. How does that help me if it's sorted in a ascending order? What if it's not sorted, or what's if sorted? Will this help me? Will this thing help me? We will find out. Okay, n is 10 to the 5. So maximum bits. So basically we need to construct a number uh, which is which is 2-bit. Okay, so let's just say we have a 0. We have 2 bits, all of having zeros, and so for maximizing maximizing a XOR, basically this XOR will be a number, and for maximizing a number we will have to like have most number of set bits. So the more the number of set bits, the more bigger the number of is, and the more the maximized it is. So in order to find a number k which will give us a maximum, we need to have a bit set in this position. So in 1, if there's 1, so we have to put a 0, because if we put 1 here, then it will become 0. So we don't want 0, we want 1, we want the bit to be set. So in order to set this bit, we need to have a 0 over here. So whenever there's 1, we will have a 0, and suppose if we have a 0 here in case of 1, then we have to add a 1 here. So basically here what we are doing is we are like flipping it. So we are flipping the bits of the XOR, and that will be our k. So, and this will give us the maximum bits, and the bits will be always the answer will be like the whole maximized answer will always be the number of all set bits with a maximum bit. So basically, as you can see here, maximum bit was 2, so the answer is 2 to the power, basically this is 1 maximum bit minus 1. So basically this will set all the bits until maximum bit, so all the bits are set. That's why we can see here the answer is, for bit 3 the answer is 7, because all the bits, if you set all the bits 1 with 3 bits, it will become 7 number, and if you set all the ones in 2-bit number, so it will become 3. Okay, so this is the thing, and so the answer is pretty simple. What you need to do is you need to make the XOR, you need to have a XOR, and let's flip it, and that will be the answer. Okay, so for example here the XOR is 3, and you flip the XOR numbers, you will get basically we will get, if 3 in binary is theirs, and you flip it, and it will become 0 0, and 0 is the answer. Then for another one, we have to remove it. So for removing, um, what removing we can do, like we can have built-in functions in our vector. So I'm using C++ Window language. You can have their own built-in functions, and you can like remove from the back and keep removing it. And what the thing is, if you remove and you have to like recalculate this XOR again, and then for each iteration you have to like recalculating the XOR. And I think our constraints, yep, 10.5, they won't allow us to do this. So we had to like find a clever way to find XORs efficiently without, and also that XOR should be like removed. So what we can do here is what an efficient way to like calculate this. So for what that we can do, mm, uh, something called prefix sorts. So a prefix sort is nothing but you have a prefix sort is, suppose for this number is the prefix sort will be 0 XOR 1 XOR 1 XOR 3, and now this is your, the answer will be 3. Now you have to like remove this, and now you need this prefix XOR. So in order to get this you need to remove this. And how you can remove this, you can like XOR it again with the same last number, 0 XOR 1 XOR 3 XOR 3 XOR 3. So what will this do? This 3 will and 3 will cancel out each other. So in XOR, it's a property of XOR that if two bits are same, the answer will be 0. So like, so 0 XOR 0 is 0 and 1 XOR 1 is 0. So this will cancel out each other and the answer will be 0 1 XOR 1 XOR 1, and which is again 0. So now that is the thing. So you just need to flip this and that will be the answer. So I think we have figured out um, how to solve this problem. Let's see if we have missed anything. I think a dry run will be sufficient. Let's see the dry run. So we have this XOR. We will take the whole XOR of it, and then we will flip the XOR on each, and then we can do a prefix again, and then we can do prefix again, and then we can do prefix again. And this way the time complexity will be, so the size of the array, which will let's say O of n, and for each time we are flipping bits, and flipping a bit is, and the maximum bits can be 20, so we can treat 20 as a constant here, and the overall time complexity will be O of n, which is good as our constraints. And I have also noticed one thing, like we don't need to use prefix, or we can simply go through each element. Suppose starting from the 2, if we start with the 2, we know the XOR is 2, and this XOR 2 will be the answer to the last query, fourth query. So we can like update the last, we will have a result array, and we can simply update the last index. Similarly, the next one we can have like 2 or 3, and then we will update for this index, then 2 3 4 we can update for this index, first index, and like finally for 0 index we can do that as well. Okay, so I think we can code it now. I still don't understand why it is sorted, how it will helping me. It's just for normalize, like just for making confusion, or it maybe something in the sorted one can help us. No, I don't think so. Let's just write a code for it. So this is a function which will get nums, and I will get a maximum bit, and I will have to return a vector of int. So let's first make a vector of int. I will call it result, and this is our size, basically n. N is int and equal to nums dot size. So basically this is the size. If we calculate the size of the array, we have nums and we have make the result of size n. Okay, let's do what we need to do is we need to loop through each of the element for int I is equal to 0, I lesser than n plus plus I. And then what we need to do is we need to put a XOR, and then we will like to flip it, and that will be the answer. Okay, so let's say we have a XOR variable, current XOR, and it is 0. So each iteration we will XOR it with the current element in nums. After XORing it, we just need to flip it. So, and flip at which position? So for first it should be the last, because this array, the answer to this query will be the answer to the last query, as we discussed earlier. So for this calculation we can use result n minus 1, which is the last index, minus the ith index we are at, and it will be get flipped. And I just create a function, that will like flip the number for us and return it, and that will be the answer to that. And in the finally we can like return the result. Then I think it will be fine. Let's create this flipped function, so it will return us an integer and integer named pet flipped. It will take a number, let's pass it by a reference, and it will flip it, right? So but we need to flip it under like a maximum bit, so we cannot like flip it like whole. So a number is basically 32 bit, but we have to flip it under a constraint of maximum bit. We'll have to pass this as well, maximum bit, and what we will do is we'll have a number, we call it flipped num is 0, and what we need to do is we need to go all the bits, and I 0 to maximum bit, and we only need to, if it is a 0, then we need to flip it. So if we need to flip the number, right, if the number and one left shifted to ith place, if it is 1 in the number, we don't need to do anything, but if it is 0, then we need to do something. If it is 0, so basically our flipped number is already 0, and we only need to like flip those when it's actually 1. If it is 0, then we need to flip that number. So flip num or equals 1. In that case, one, so yes, they can do that. So if we are flipping that number at this ith bit, and we are ORing it with the 1, so that is that and happened, and then the next bit we will move on to the next bit, and similarly we will flip the whole number, and after this we can like return the flip number. And I think we are done, so let's just run some test cases to see if we actually passed. Okay, so we do passed all the test cases. Let's give us submit. Fingers crossed. Boom, we submitted, and we are at 34.29%. That's a shame. But people use macros, so I can also use a macro for that, and we can like boost it. But that is just a hacky way, not something. Okay, that's it. So that is it for the today's video. We have solved this problem. I don't think that should be a medium, because yeah, but if you don't know about XOR, then it's definitely a medium for you. But okay, hope you guys like this, and I see you. Any feedback you um, don't understand anything, if you don't like the way I explained to you, because I am preparing for the interview, so please put your feedback in the comment section. Thank you.